Oh, wait. It says reconnection successful, but we're still dropping buttloads of frames. I'm going to... Oh, wait. We're green. We're green. Comcast decided to let my information through. They reviewed the Sidney Coleman video and decided it was not in fact porn. And we are back. I mean, last time I showed a video that I really liked, I got banned for 3 days. So, you know, it could have been a ban. I didn't know. Yeah, you don't... Some people, longtime visitors to this channel, remember when I got banned from Twitch. Maybe find another ISP. Yeah, I really want to get out of this apartment. That's the only reason why I haven't switched ISPs, is I really want to leave. Was it the 7-minute abs? No. I didn't get banned for 7-minute abs. Like in 2015, it was a while ago, yeah. It was a while ago. You know what? I'm just going to make these S64. And we're going to take the type error that way. And you know what? We're just going to do this. We're just going to break everything. Actually, no, let's not do that. Okay. I'm just going to make these U64s S64s. Because I just know that that's what I'm going to want. So be it, baby. All right. How we doing? 1413. New York Times' 1413 project. All right, 1431. It's about time for me to sort of take at least a short brain break so I don't... Like all of these buffer underscore, I have a feeling we're going to remove the buffer underscore and just have them be local to the file, you know? So anyone who was in the discussion about from the other Saturday about, hey, are you going to do closures or whatever? This is what I'm talking about. Like anytime that you have a callback, you're also going to have a data pointer. Like that's just how it works if you're being reasonable. So like function values might as well have a pointer slot, right? Bob, VP of Comcast. Is this for use in the game? No, it's just for people to have around. You can exploit the context system if you want closure-like behavior. I mean, sort of. Like that'll work for some cases for sure. It'll let you avoid having global variables for sure. Yeah. That is true. That is true. But it doesn't help you, like, if you want it to be stored on a data structure somewhere necessarily. I mean, you still have to have those two things and pass them around. Should not also have a user data size. No, that user data, typically in a C program, this is not a pointer to some allocated memory necessarily. It's just a pointer. The way these work is, well, you get some data and the system just passes it around and gives it back to you. The meaning of this is up to you. It could have an arbitrary size. It could point to some allocated memory, but this system doesn't know or care. That's like how C programs do it. Like, why is this even a thing? This program is full of stuff like this, where there's just too many wrappers. Anyway. Okay. Yeah, whatever. Whatever, man. Oh. We don't have file seek, I don't think. So we're going to have to deal with this. Like FTEL? Seriously? That's so gross. That is gross, dude. All right. You just shouldn't have like an FTEL in the middle of... Yeah. It's gross. All right. It's fine. I mean, it seems like mostly reasonable code, so when I complain about something like that, it's actually kind of minor. It's kind of minor 49er. Mem move. We actually don't have a difference. Oh, mem copy, sorry. Buffer rewind. No, this is what it was, wasn't it? Like, it's literally just seek to 0, which is why I think it's stupid. Just call buffer seek with a 0. Why is an FTEL gross? Because you don't know what that does. And like, why doesn't your buffer know what the file position is? You know, it just... Like, it's not like someone else is going to be manipulating the file. Does memcopy support overlapping memory? Probably not. We probably need to do something about this. We just didn't do memmove because I just hate that complication in C. So probably we would do something like memcopy, comma, overlap, or I don't know, something like that. We'll think about it. You know what? Let's do this. I hate this the C style thing that nobody ever uses. What are our parameters? Just the target data. File target data bytes to read. Get out of town. All right. All right, short brain break. How's it going, everybody? We're up to line 1508. That ain't nothing. Let me warm up some more tea water. When using, can you accidentally shadow struct variables with local variables? No, I'm not really. Like, You can, in the sense of if you do it in a local scope, but that's the same as any shadowing. If you do it in the obvious way, like two usings that go into the same scope, then you'll get an error. Okay, we're back, everybody. We're just, this is the USA now. This is just what happens in the USA. Mentioned that you watched my videos in an interview today, and the interview seemed kind of put off by it. What kind of, was it a programming interview or like a game design interview or a, I don't know, a different kind of interview? What is self in buffer discard red bytes? Well, it was supposed to be buffer, right? I've probably made lots of mistakes like this that we won't see until later. Actually, let's do this. Yeah, we're going to take the word buffer off all of these eventually, too, because that's annoying. Game programming interview. Oh. Like at a company somewhere. Like at a big company or a small company? We got another tea steeping on deck here. Big one. Okay. What are the best career paths to aim for in terms of profitability? Central banker. Like, why are you asking me that? Dictator of North Korea. That's pretty profitable. In terms of jobs that are software related, write a computer virus that infects everything and allows you to take over North Korea. Yeah, Jeff Bezos' ex-wife. I hear that's very lucrative as well. You are correct. Very lucrative. I said I wanted a break, but all of a sudden I'm typing again. Wait, what was buffer read supposed to return? I deleted that part. Is this literally reading one character at a fucking time? No, it's at least 4 bytes because it... What the fuck? Okay, hold on. Let's go to... All right. It reads one integer at a time. Oh my God. Okay, well, this isn't going to be the fast MPEG decoder, but that's okay. That's okay. And it's like doing it, you pass the number of bytes. And it's like a number, oh, 12. Wait, what? Wait, what? Why is it 12 bytes to read the width or the height? What is going on? Does someone want to help me with this? Oh, this is number of bits. Holy shit, this is... Okay, this is the format. You shouldn't just say, like, if something is in bits, you should say it's in bits in some way, because that's unusual. So this is in bits, I think, as well. Why no I-32? Because I-32 is a dumb name. If your numbers are different depending on whether they're signed or unsigned, then say S for signed and U for unsigned. Don't say I and then U. Like, that's weird. You know what I'm saying? I don't know. It's fine. It's honestly, it doesn't matter either way. It's not one of those things that's important. Okay, so no wonder it reads a... Never mind. I was blaming the author that this reads a small amount of thing at a time, but you can't really do better than that if it's like arbitrary bits. Now, it may be that zooming out at a higher level, you know that these bits are aligned in a certain way, and then you wouldn't have to do this. So we'll see. We'll see long term. But yeah, for now, it's just gross. Okay. We could put all the buffer things in their own file, right? Because it doesn't have to be single file here. It doesn't carry the same advantage or disadvantages in C. Let's just do this. Like, look at, this is all buffer things that we're doing. Right? Maybe we shouldn't do this. I don't know. At the end, if I'm sad, we can put this all back into one file at the end. But like, you know, all that buffer stuff and then all this demux stuff can go in its own file. And then video. And audio. Yeah, I don't know. Anyway, if we don't like this, it'll be really easy to put these files back together because you don't have to forward declare anything in this language and whatever, so that's fine. We're going to say load audio, load video, load demux, and load whatever. What was the other one? Buffer. Now, though, we're not going to have a linear notion of success anymore. Let's see what happens when we do this. Oh, whoops. All right. Actually, this is bad. Let me put this on the to-do, because we didn't get a good file or line number. There. That is bad. Okay. But we're not going to worry about it. Okay, audio is now complaining, even though we were doing buffer. Let's do this with no jobs. So hopefully we get the same order all the time. Demux. Demux is now complaining. Great. 467 lines. We know it's demux because that's what file we are in. I don't like the using floats for time as well, but I don't know. Start, is that a Boolean? No. Oh. I don't know what that is. All right. Actually, these are not pointers, right? Okay. This we don't worry about. Okay, we are getting separate parse errors per file, so that's cool. All right. So for people wondering, somebody asked this earlier in the chat, like, why don't I just try to use an autoconverter? We do sort of have an autoconverter that someone wrote that I don't think would necessarily handle everything correctly. But for me as a language designer, when I do this, I get to see firsthand, like, what should this code turn into? Like, it just helps me keep it real, you know? Like, I see the places where we save code and all that, and the places where we don't, and the operations that are maybe less convenient, and the ones that are more convenient. And it results in a higher quality example than if you just run an autoconverter, right? Like, this is code that I think we would like to take care of over time and make better and all that. So, you know what I'm saying? This is all weird, like, has headers, I guess, means have we loaded them yet or something, as opposed to, like, does the thing have headers? Autoconverters rarely work properly either, even if you wrote them. That is correct. I mean, like, look, here's the thing. Auto conversion is well defined if your language is very close to the source language, right? So you know how when you play a video game and they have the alien script that you learn, and it's really just the English alphabet with different symbols, right? If that's what you have, then of course you can convert that, right? But the more that your language is interestingly different from the source language, the more that the result that you want is not easily predictable from the source, right? And requires human intuition to find the best version. And again, as the language designer, you learn more, right, about what things look like in your language and all that. Because this is another thing. Like, I program in my own language all the time. I write things in my personal style, right? Here, this is code in somebody else's style, which is not that different from mine, but a little bit different. And so you just see, you know, to what degree does the language accommodate that style and so forth. It looks a little tedious what I'm doing, and it is, but honestly, to be good, sometimes you need to work in the coal mine and do tedious things. You know what I'm saying? It's just part of it. It's just part of it. All right. I'm almost tempted to do a using here, but it's not for now. All right. Like, this whole, like, I don't like calling, this is a stylistic difference, like what I was talking about. I do not like calling non-trivial functions inside an if. I just don't do things that way. I'm not gonna just go restructure all that stuff right now, but it's like, you know, I don't like it. I just don't like it. I think ifs are for testing. And if you want to do work, do the work before the if. Like, this is kind of passive-aggressively weird. It should say, if the start code is not equal to start pack, open brace, result equals this. If that's -1 return, we're just going to do that. Fuck this. Like, this is way more readable to me. Than the other thing. Like, this just makes sense to me. Oh, this is probably it. Oh, these aren't enums. They probably should be. Have I ever talked with Bjarni Strostrup? I have emailed him, yes. I've had an email conversation with him before. A long time ago in a galaxy far away. Okay. See, whenever I do this, I might break something, but honestly, I would much rather just do this. It's just so much more sane and readable to me. Okay. Dmux goes to 113. Hey, there we go. I feel like I'm going to remove a lot of these prefixes. Like, why is this here? Who cares? Just call buffer seek. Like, what? Anyway. I feel like there's just too many layers of indirection for what is here. It's another one of these. Like, okay, so great. Okay, that's weird indentation. Wait, do these get set? No, that's literally a constant. Literally a constant. Okay, great. Let's try this. Somebody suggested before using defer to do like the loop condition, like here. So we're just going to try doing that and seeing if we break something horribly. Wait. I'm sure I've introduced all sorts of stupid logic errors. All right, great. Oh. Whoopsie. All right, 185. 221. We're not quite halfway through demux. Yeah, defer is block scope. Defer basically, it runs at the same place a destructor would run in C++. How do I decide what to do next? If you make a big complicated decision process out of what to do next, then you'll never do the thing. You'll just spend all your time thinking about the thing. What is my favorite romance anime? A strange game. The only way to win is not to play. Dude, like Japanese anime nerds who grow up to be anime illustrators and writers have the right things to teach you about romance. Are you kidding me? If you want to learn about romance, go somewhere else. Like, Although before I knew better, I did watch a lot of Kimagure Orange Road. Same could be said for Hollywood scriptwriters. Yes. Oh, definitely. Very definitely. Orange Road was at least in the times where the industry was not as inbred as today. That could be. I have not watched anime in so long. I have no idea what it looks like these days. All right. We're just applying the same things here over and over. Great. Let's just do all the cells. Let's just do it in the whole file. Screw it. Screw it. Okay, where did I leave off? Let's just let it tell us. 221. This is kind of scary. What is our packet invalid? Where is that defined? Okay. We're just going to do a clamp, guys. Oh, I forgot. I was trying to avoid that because that's in BASIC, but we're already using like new and alloc and that stuff, so it's no big deal. All right, so that means I can go back here. This clamp is there, and then all right. Ew. All right. Whatevs, man. Okay. I don't like this, like, this is a different stylistic difference. I want to see the else's. I don't want them, like, down. This is just the way I do it. It's not necessarily, like, better, but... all right. Well, so just because we get this far, by the way, doesn't mean I didn't make mistakes. It just means the mistakes might be something like an undeclared identifier and stuff, which it can't know that it's undeclared because it might be in global scope. So we need to be able to, before we can even report undeclared identifiers and stuff, we need all our files to be able to compile. So phase one is getting all the files compiled. Do I play Go? I played a small amount of Go. I'm not good at it. I wish I was good at it. You know, this should probably be an enum, so we don't need the packet prefix. Okay. Whoops. Ever hear the books The Art Instinct or The Mental Life of Modernism? I have not heard of those books. Should cast packet.data I to S32 and do a single comparison. Yeah, you still have to do endianness in that case, and I just don't want to deal with it right now. But yes, if you were making the code faster, that would probably be faster, although you might expect the compiler to do that for you in that case, depending. Let's just be extra sure in case we ever change the precedence of cast. Yep. Great. Hey, we're at the end of the file. All right, well, Dmux is past the parsing stage. That's great. Today is Sidney Coleman Tuesday, which is like Taco Tuesday, except instead of tacos, we have Sidney Coleman. Have I seen Spirited Away? I actually have not. I think this is the one with a ton of, oh God, this is going to be really gross, guys. We might use some bakes here instead of some macro. Oh, we're going to do some polymorphism. That's going to be fun instead of shitty C macros. Oh, look at all the shitty C macros, guys. Oh my God, that's going to be good. Okay, that's a bigger file. Let's not do that one yet. Let's do audio. Smaller. How about buffer? We were halfway through buffer. Let's just finish buffer. Like, are these signed or unsigned? Like, I don't know. Which, by the way, is something that C code does get very sloppy about sometimes, and something that you maybe do want to clarify, which is another reason not to use an autoconverter. I mean, I think the start codes should be U8s, I guess. Like, Wait, what? You return -1? Buffer has start. What? What? Why are we checking this against -1? Like, just say true or false. That's very weird. I mean, I sort of get it. I sort of get it, but we're just going to return a bool. Because we know I think they're just trying to do a very tweaky optimization that is not worth it in modern computers. Yeah, it's like maybe we should just return a success code as well. Okay. You know what? I'm just going to make this ugly. Let's just do it ugly, guys. We're going to break things. We're going to move fast and break things. We're going to move slow and break things. Like, part of the reason to go more strongly typed than C is like, yeah, you know? So we're going to make that start code in enum and stuff. This is kind of gross, but okay. All right, well, that file parses. I'm sure it will have many problems now. Return true, not current. I think I fixed that, right? Anyway, we'll see. All that's going to break real bad when we try to compile. Let's do audio. Why are layer 1, 2, and 3 defined as the opposite? Dude, who even knows, man? Why are these signed short and the other one's unsigned? I don't know. Whatever, man. Let's see if this works. Hell if I know if this is going to work, but we'll find out. Also the audio underscore, let's just get rid of that. Screw that. All right. So we've got tables. Static const uint8t. Something like that. No. All right. This is a thing we don't do. They're using the implicit, very error-prone feature in C that if you don't put all the things, you automatically get zeros. They're actually doing that up here too. That is bullcrap. We do not support that intentionally because it's an amazing way to make mistakes. Someone said something wouldn't fit in S16. Oh, I meant U32 here. Sorry. Yeah, that was my mistake. The compiler would have yelled at us for that, but thank you for catching that. Yeah, so we're going to put the zeros in because this has burned me so many times in C. 5, 6, 7, 8, 9, 10, 12. So we need 20. $11. It's 30. Why are they defined as 32? Is that for alignment or something? We'll see. It'll yell at us if we got it wrong. Yeah, so that's happening down here as well. I think this is a U8, right? Two, three, four, 5, 6, 7, 8. 16. And I guess I should line these all up, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. All right, fine. Okay. Oh, these are not. Lol. I changed these to squares, and they're not squares, guys. Lol. Okay. I don't like multi-dimensional arrays. It's just my personality. But whatever. Okay, wait. This pointers to, see, I never remember if I have to reverse the dimensions or whatever. Do I have to reverse the dimensions? Because they don't make sense in C? I think so, right? I think this is... right? No? Shows you how often I've done this. Wait, in C, when you do a multidimensional array, you say, look, it's an array of 2 elements, and then there's 32 of those, right? This says there's 32 arrays of 2 elements each, right? No, it's like you use it. Oh my God, it makes no sense. Right. No wonder I never do multidimensional arrays in C. It doesn't make any goddamn sense. All right, we're going to do it the same. What the hell is this? Oh my God, my eyes are bleeding, guys. Oh boy. My eyes are bleeding. I have never, so in my earlier days of C programming, I would use 2-dimensional arrays before I learned never to do that. I have never made a 3-dimensional array, I think, in my life. All right, anyway, let's see where we're at here. Okay, mistakes were made. Fortunately, that was an easy clap. Easy clap. Okay, I'm going to take a short brain break again and load up on some more chocolate and sun chips. Or maybe a little bit of turkey with some mustard on a plate. How's it going, everybody? What's up? because I am such a healthy eater, I have Amazon fresh turkey slices, so you know they are fresh, with honey mustard. Any biotech startups I'm excited about? I am not very educated about biotechnology startups. I know someone who is much more educated about that than me, but I have not asked her what I should be excited about. I should have done that when I was hanging out with her this week, but I didn't. What about bread? Don't you know carbs are evil? Carbs are evil, and bread has carbs, so I'm going to have turkey with sun chips. You wish there was a way for individuals to fund startups working on cool stuff before IPO. I mean, in software, you can do that. You can go on AngelList or Y Combinator or something, right? It's probably larger amounts of money than many people are like for AngelList, you pretty much, I mean, it's maybe like if you join a syndicate, you could put in $5,000 per company or something, which is pretty small. But it's not like Kickstarter level, right? But I don't know how many biotech companies there are on a place like AngelList. Maybe there's a lot. Don't you need to be an accredited investor? Probably. I do believe they loosened up the requirements for accredited investor a couple times in the past 10 years, but I don't remember what they are now. Sun chips with honey mustard is actually pretty good. I'm just going to go there. And now I am drinking green tea out of a mason jar. Am I thinking about adding new ways of initializing stuff to solve problems like this one with zero initialization? No. I mean, here, if you mean this code right here, what this looks like is this. Right? Like, okay. Well, there were no more of those. Malloc plus memset rather than calloc. Yeah, I mean, I never used calloc back in the day. I don't know. I just think it's silly to have an extra function for that when in fact it probably doesn't matter. A while back, I was about to answer a question on the variable shadowing with using. I mean, it's just like regular shadowing. So, excuse me. If you try to do it using in the same scope where another variable is of the same name, then you'll get a redeclared variable error, right? But if you do it in a subscope or something, you shadow as normal. Okay. Wow. Wow, this is gross. Okay. Whatever. Whatever. I don't even know what that is. Like, this is just a very object-oriented way of doing this. I wouldn't have these even. It's a whole deal. Yeah, these are U16s. Okay. Fuck you. Okay. Okay. Oh no, they're using the implicit I after the end of the loop. Oh, don't do that, guys. Right? Let's get the PLM peg out again. Don't do that. Don't do that. Yeah. Yeah, gross. Gross. All right. This is a bool. And I is audio.buffer.length minus 1. Just make that readable. I is audio.buffer.length minus 1 because otherwise you break or return. And then plus 1. So it's audio.buffer.length like again, that's almost like trying to be a tweaky optimization or something. It's not implicit. Yeah, that's what I meant though. Like, never mind. You know you see what I meant. You see what I meant. What do we return from here? Frame size. I don't know. You need 48 bits. See, this should be like returning error codes and stuff rather than 0. It's like, ugh. Like, if you don't have enough space, you should... You know what I'm saying? Okay. All right. Where are we at? $416. Oh, we left a question mark. Or I. $433. Actually, all this stuff, this should all be enums. Like, whoops. We're just going to take the pain. Just going to take the pain right now. That's an audio mode. There's just too many integers. You know what I'm saying? This is just gross. Audio mode was U32. Yeah, but it doesn't matter. It can't be. It's only 2 bits worth of information, guys. Yeah, we made it smaller. It's fine. This code idiomatically uses int for a lot of things. If we break something that way, we'll unbreak it later. Like, very clearly, I'm going to break some stuff. Like, so if I'm somehow perfect here, then we just have to fix compile errors and then it'll run correctly. But I'm suspecting that it will not run correctly, right? Like, I will have just broken some stuff. Why was tab 3 declared up here? That's so weird. All right. So this is weird. See. Yeah, we never modify these. So they were... Oh, well, we do by shifting right, but that doesn't... We never need to make these bigger, so they're like U8s, but the code was a lot... Yeah, it's fine. Whoops. I did 0, 0 instead of dot, dot. Lol. All right. I don't know what any of this stuff does. I don't know what size. Out, pause. I mean, I don't know. That's 64. Who the hell knows? Dude, what is all what? I mean, one of these, I guess this is the left or right channel, like, so it's hard coded for mono or for stereo maybe. But then this one, the 0, 1, 2, oh, that's the, I don't know what that is. It's just gross. I don't like multi-dimensional arrays. I don't like them. Let's see where we're at. 437. Oh. Okay. We don't do shift equals right now, which I may enable that later. Okay. Oh. Oh boy. So they're using this thing that we don't do intentionally once again. Oh my God. Wow. Okay. I almost screwed that up. Okay. What is this SF? Oh, oh my God. Okay. I'm sure if I read the spec of the file format, it would make more sense. All right, we're down here, which is where we left off. Like, okay. I guess that's a thing. Great. Like, at least multiply, guys. Oh, okay. What am I doing? I'm having a rodeo. Oh God, there's a subscripted index plus pluses. All right. This is not C++, therefore we do not support plus plus. $5.98. Looks like a C-style declaration. In fact, it is. Although not, the const is not right, but whatever. Don't you get that for free if you multiply by 1 divided by that? Yes. So ideally you would store a constant. So I'm just not doing this kind of thing right now, but ideally you just have a constant at the top of your program that's 1 over that, and you do a multiply, and it's a lot faster. Now, the compiler may convert this division into a multiplication, but it might not. So, like, technically it can't unless you compile with like lax float integrity or whatever, because you can have a different rounding result. So compilers may not do that for you. Fast math. In my brain, we do fast math. What is SB? It's SB limit. It's less than frickin' 32. Whatever. We'll make it an int for now. Who cares? I am not sure. We're going to see what happens there. Okay. Oh boy. Here's some fun ones. Okay, guys. Yeah. What do we pass in here? Audio.sample. These are S30. All right. We're not F'd. What are you talking about? There's no F. There's no F. No F. Oh boy, look at this matrix math. That looks fun. The code broke the stream. In this language, we don't suffix our float constants with F. All right, we're down to one file, everybody. Well, for this part of the thing. What are those numbers? It's just, this is a matrix multiply, probably. I don't know. Oh, this float shit here. Yuck. Actually, we don't need that. Never mind. Because, oh, no, we do. We need like half of them. We don't need the ones on the right. Because we get that from the multiply, but whatever. We'll leave it for now. Why's my alarm going off? I think I set this for tomorrow, but I set it for today, you know. All right. TO1 is missing the cast. Oh, yeah. Oh, that's why it was in a weird place. Okay. But that just goes to show you we're just parsing right now. So we even parsed that for some reason. Probably as a function call or something. So yeah, there could be lots of problems. We may not do all of this tonight because if I get tired of the drudge work, we can go to something else. All right. Invalid start is slice. These are start codes. Okay. Great. Wait, wasn't that... Those were audio modes. This is slice first. Like, what a bunch of banana cakes things. Don't we have other start codes in the other files? I swear we had a start code declaration. Like, whatever. Wait, what? What? Oh, yeah, this is scary. Okay. Okay. Do we store multi-dimensional arrays as arrays of pointer length pairs? Or are they treated as one block of memory? I mean, they're treated as one block of memory. We don't insert anything in that case. I'm actually not sure why they're representing these this way, but whatever. So many tables, guys. We're really going to be testing our literals here with all these tables. Golly, golly, golly. All right. Wait, what? Oh God, this is like, oh, pointers. Oh, this is going to be a test of some things right here. I don't think we've ever done this. Yeah, we'll see what happens. Okay, that's some tables. Well, we made it up to 414. Motion. Whoops. That was a goofball right there, guys. That was a goofball. How's it going? Is this how you succeed in the games industry? Well, that is yet to be seen, if I'm being honest. All right, so this is not going to happen. Great. Let me get some more tea. How's it going? We are more than 1/3 of the way through the syntax pass of this file, which is the final file. And then once we finish the syntax pass, we will be assaulted by many errors. And if I get this to compile tonight, that'll be all right. Hopefully we can get it working. We'll see. Yes, the beta testers will get this. VK get physical success in the game industry. Well, that's if you want physical success as opposed to mental success. I don't like using the floats for frame rate. Just this kind of crap, like, don't do that, guys. It's like the bad thing that you learn in school. It just adds up to a bunch of nonsense over time. What? Just do that. Okay. Okay. This start code, yeah, like, it's just, I see what they're doing, but it's a little bit gross. It's just not worth the complexity. Boy, my eyes are getting blurry from staring at the characters. Like, even this. Like, this loop, it keeps boiling down. This is for IDX zigzag. Right? Like, people think C-style for loops are good, but they're not really good. That's all I can say. All right. Let's just do this. Are curly brackets mandatory for if blocks? No, they are not. Like, what? Why are you asking that? It's on the screen. This is going to be so messed up, guys. It's going to be so broken. You won't even believe it. You will not believe your eyes at how broken it will be. We're going to see spam. It's going to be great. I'm getting hungry again. F code. F code. How broken do I think it'll be? I think it'll require significant debugging. Possibly have compiler features. Like, that's always the fun part. Yeah, zigzag is some array literal. We can go up there and look at it. It's this thing. All right, great. F code. F code. F code. F code. Nope. I typed all that just in case there was another one. You're copying the frame data? Okay. Okay. It's reading one bit at a time, dude. Oh. But I guess that's how it goes. It's probably only a small number of bits. I don't... not sure I like that. Ugh. Okay, where are we at? Oh, it's not constant. Didn't read far enough ahead. All right. 909 out of 1321. We're getting there. We're getting there. Oh my gosh. The grunt work. The grunt work. All right. All right, now we're going to get to the fun parts. The terrible C macros. We're going to take a short break before we do the terrible C macros. I might add the less than less equal. You know what? Let's write that on the list. People might appreciate that. All right. I missed an else statement. Something with OX3F. How many files ago was that? Oh, you mean while I was doing the loop termination condition? Yeah, I pasted something in there temporarily. Like the while or something? I don't know. Was I so tired that I deleted something important? Let's see. CBP : equals. Oh, decode macro block, right? Yeah. So this was. Oh, you're right. Oh, I did delete some stuff. Thank you. Okay, hold on. Hold on. If the macro block type and 2, else if self.macro block intra CUP equals OX3F. Yeah, I spaced on that part. Very good. Very good. Well, we're not home yet. So we have this PLM block set macro, and it looks like that's, oh God, yeah, okay, that's a macro so that they could pass different variables in and stuff. Except maybe not. Let's look. No, I think it's just to try to be fast. It's because it's in another macro, but like, all right. We're going to have to figure out this bullshit. This is what's going to break right here. Okay. Okay. This might be the hardest, most annoying part, depending. I think we're just going to do this. I don't know what dest is. This is D. That's a U8. Dest index is DI, which is a U32. DW and stuff is S32. This code is honestly pretty inconsistent about what types it uses. Source index. Oops. Just get rid of this so I can indent it, please. And then this while false, just to make a scope. That's a classic C situation. So block size is an S32, and op is op, which is, okay, that's a code. That's code, which is fine. We can do that. We can do that. I actually don't know if we can do that expression. I think, I don't know. We'll see. Was that a do while false without a break? Yeah, it was just to make a scope. Because I think in C, sometimes you can't even have a blank scope. It wasn't legal originally. Something like that. Like, there's lots of old C tricks like that. The source index is what? It's argument 4. SI, which is C senor, a U32. C senor. Okay, that's some, I don't know if that's really what that's going to be, but it's something. All right. Major League Baseball case. All right. Okay. We can't do macros inside Switch right now, I don't think. So this might lead to compiler feature. I think we're gonna maybe. Gross. Something like that. Wait, what? Never mind. Sometimes those were superfluous, but other times they're not. Look at all that fun code, guys. I don't think this will work the way things work right now. I highly doubt it. We'll see. Index arguments need to be pointers, since they would be reused in multiple calls. What index? The capital I index? These ones? Source index, dest index? Yeah, that is correct. That is correct. Good catch. Good catch. Something like that. This is going to be a good test of macros. It's going to be really fun. But I'd wanted to hammer on macros some more. Anyway, so this is a good opportunity to do that. Yeah, about what I said. We're just gonna comment this out for now and do the rest, because like it's not gonna do this right now. So we're gonna solve all our other problems. Oh, somebody got the bot, I guess, that I wasn't watching. That's great. That C macro had minimal benefit. Yeah, we'll have to look at it and figure out what it should be. Like, either the macro system needs to be better. I mean, it sort of looks like you should just type this out, right? Like, here's what I don't get. These are all constants. And there's only one thing. Right? So, like, if... in this case, why is anything happening? Like, why is this here? Because this will never be true. You know what I'm saying? Anyway, we'll look at it. We'll look at it later. Anyway, I just want to get the file compiling, the rest of the file, and then we'll go back to that. Because I'm going to want a brain break and... Okay, yeah, I should really have had operator shift equals. If I'm being honest, I really should. Why do people, a lot of people seem to not like the implicit Boolean in if, and they seem to want to like do not equal 0 and stuff. And I never understood that. It's so much better to just use the thing. Now I feel like I deleted an equal 0 before instead of a not equal 0 because I almost did this here. Yeah, if condition is equal to true is equal to true. Totally, man. Totally, man. So much stuff is going to be broken. It's going to be crazy. Wait, what happened? Oh, what was block less than 4? Okay. Boy, this sure looks fun. We don't have a step in our for loop. Okay. THX 1178. All right. All right. We're getting down there. He writes extra is equal to false. Should defer? No. The whole reason for the defer is to put it at the top. These macros might actually be fun, depending. Let's see. Let's get rid of the backslashes. Because these are defining functions for different sets of parameters, right? So what we can do is say, instead of these, right, we say well, let's get rid of the PLM underscore. All right. So these are going to be frame to RGB is bake convert function bake arguments so we can do that and do the non-macro version of this, which is pretty cool. Right? RGB, BGR, RGBA, BGRA, RGB, BGR, right? Okay. 3012, these are all 4, wait. So that's 3, 4, 4, 4. So O, 2, O, 2, 1. So this is just the index of the channel. This is exciting because anytime I get to use bakes for a real purpose, that's pretty good. So the great thing about these is these will turn into optimized functions for these different cases that you can step through in a debugger, unlike the shitty C macros, which you cannot step through in a debugger. F, 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 F. They turn into optimized functions that you can actually step through in the debugger just like regular functions, unlike in C or C++ when they're macros and you can't step through them or see what the hell's going on. In C, as soon as you make a big macro like this, you kind of dread it because it's impossible to debug, right? Okay, so this is convert function, right, is, and then you, okay, frame is a frame, dest is a pointer to U8, stride is S32, and then we'll put, okay, so we're going to do that, and then we have our PLM put pixels here, which we haven't dealt with yet. So we're just going to leave those for a second. Okay. Except I called these R, G, and B, and bytes. Let's leave these the original names for now. It's going to make the bakes more annoying. We can make that more attractive later. Okay, so we do these bakes. They get the same variables. We do all these things. Okay, what the hell is put pixel? Like, why? This is, oh, yuck. RIGIBI. So we call it with y offset 0, y offset 1, y offset YW, and what? Yeah, so we're just doing 4 pixels. This is like an upscale or whatever the fuck, right? So each pixel is going to 4 things. All right. So this is really a macro. See, this macro was a macro to like make it do different things. This macro is like just a macro to try to be fast. That's called from another macro. So this, we could just say, right? Oh, except no, because y Y down here is being accessed. Oh, but it's low. See, they declared a local variable here, and then it's only used in the macros as a temporary. Yeah, just get out of, bro, get out of town. Get out of town. Okay. Now the thing is, dest is being used from outer scope, and D and all these things. There's a lot of things from the outer scope. So actually, maybe we do have to make this a macro, right? Like frame. There's no good reason. You could pass all these things in, right? But like that. This is going to be a good test of the macros. All right. Guys, we parsed. All right, I guess I need... Oh, this is... Oh, yeah, that... Okay. We parsed, we're on to the type checking. Y index should be backtick. You're right. We still didn't go back and do this, so hold on a second. But while I'm distracted, when I was doing this, I was like, yeah. I could see that being confusing. Is it like an array of 16 of U8 dot whatever? Yeah, I don't, yeah. Who knows? Maybe the precedence for that needs to be different. It has 14 elements, but the required number is 16. That is something that C will not frickin' tell you. Okay. That's in the giant matrices. Okay, but before we get too sidetracked, this has to get solved, and I will warm up some more tea. What does backtick do? The macros are hygienic, so they're not like C macros. So you can define temporary variables and stuff, and they won't be visible to the outside. So the backtick lets you use things from the outside. You hope that array is not used. What array? Which one? Those ones? I don't know. Okay. So in this case, it's like it's just calling PLM block. I see. I mean, this is really weird. So it's just matching this against these. But like it's doing the shift anyway. Why are we doing that? Why are we doing this shift and then matching it against a shifted thing? Like, why not just put ands? In fact, why not put, for example, if interpolate is equal to 0, this, else this, right? Like, isn't that better? And then you could put if odd is equal to 0, then these two LC, and you're like binary searching it. Do you know what I'm saying? It's like they're just making an integer here so they can switch it with this macro that also makes the integer. And then nobody ever uses those individual values. It's pretty weird. Did I see that 40 millisecond bug thingy about Netflix? You know, I saw that title come up on Hacker News, I think, and then I said, A, why am I wasting time reading Hacker News again? And B, dude, any web service is just a garbage pile. Of course, there's tons of stupid bugs in Netflix. Like, I almost just don't want to read it because I'm just tired of how stupid all these things are. You know, I just can't handle it. People are gonna go, oh, we're so smart now that we fixed our 40 millisecond bugs. Meanwhile, they have 50 times as much source code as they should have. Like, it's just not, I don't know. I'm just not entertained. When Russell Crowe says, are you not entertained? My answer will be no, I am not entertained. I just can't. They can fix it with Mighty App. everybody. Again, because we are healthy, we're having fruit for a snack. Fruit is good for you. Okay. Fuck all this. Okay. And then we're going to go maybe they're trying to be predictable about branches or something, but I don't think this would actually buy you that. Now, all these MB cases are going to, whoops. Whatever, we can deal with that in a bit. Okay. So interpolate 0, that means the first number is all 0. Odd H0 means the second number is 0. And odd V0 means the third number is 0. Let's just do this. Just for consistency. All right. Okay, so now this MB case is just going to go away. Because the MB case is, we don't need interpolator odd. It's just PLM block set, right? With like just the code. It's the following thing. It's PLM block set. We'll just call this block set. Block set of D star DI, DW star SI, DW block size, and then the code, right? And we basically just say that every time. But what's block set? This thing. Like, honestly, all these values could like just be in a struct, so you didn't have to put all these parameters. Like, it's just so much better than a macro. Like, this stuff doesn't need to be a macro. Maybe they just wanted a LUT, but it's not a good LUT because they didn't use it for any. They made it just so they could use it. It doesn't. I don't know. I don't know, man. All right. Anyway. Could I not tick more stuff? Yeah, we could. If we decide to keep this a macro, we could just tick all this stuff from in here because nobody else uses block set, right? Oh, no, it is used down here. But the names are the same, so we could still do it. Anyway. I mean, all of these, honestly, the SI, DI, and all that, let's just do that. Oh, the DW is different each time. So we're going to leave some arguments. Okay, let's do that. Source index and dest index are gone. This is a great way to break it. Great way to break it. So dest width, source width, block size are the four arguments. Dest width, source width, block size. Right? And then that'll be pasted, but it'll be very, you know, that's just better than having another macro layer, I think. Micro F, micro F, micro F, micro F. Okay. Okay, I don't even know how many times we got this wrong, but that's okay. We can get rid of the equal zeros by like swizzling these around. That's no problem. Okay, well, now it doesn't like something. Let's just... Okay, so now we're back in the semantic phase, by the way, which is great. There's an unknown number of problems here. So I think the next step is just for me to hammer on this really hard. And you know, on some programming streams, when people are working really hard, DDW is still the same everywhere. Yeah, I just don't feel like doing that yet. You're right. But I don't feel like baking that in. It's a little too much to bake in. Oh, there's the other block set. All right. So DI and SI. Anyway, so some people, when they really want to crank, they'll put on some music, and the genre of the music will differ. Like I don't know, they like metal or something. But you see, here on this stream, it is Sidney Coleman Tuesday. Yes, someone in chat knew what was happening. Someone in chat understood what I was saying. You can never learn enough Sidney Coleman, and in fact, this lecture is so good that you could not hear it enough times. So we're going to do round two. Round two. Where is it? Game capture. Here we go. Sidney Coleman Tuesdays here on twitch.tv.
Our next speaker is Sidney Coleman, who's the Donner Professor of Science at Harvard. He was educated at the Illinois Institute of Technology and Caltech and came to Harvard in 1961 and quickly joined the faculty and has received many honors for his work and lecturing in theoretical physics, most recently the Dirac Medal from the International Center for Theoretical Physics. He's a fellow of most everything, and today, in order to tell us about quantum mechanics in your face,
including some that are illegal,
he's made the supreme sacrifice and gotten up before noon.
Okay. Well, Howard, there was one stage where it would be more convenient for me to have a second projector.
I'll see if we can.
Okay, it's not essential. This lecture has a history. It's essentially a rerun of a lecture I gave as the Dirac lecture at Cambridge University a little under a year ago. And there's a story there. I had been asked to give this lecture several years ago, when it was 2 years in the future. And of course, when someone asks you to do something 2 years in the future, that's never. You always say yes. And the time came, I got a communication from Peter Goddard at St. John's College, who was running the operation, who said, what do you want to talk about? And I said, I don't know, who's the audience? And he said, oh, it's pretty mixed. You'll get physics graduate students, physics undergraduates, people from chemistry and philosophy and mathematics. And I thought, these are not the people to whom to address on the subject of non-abelian quantum hadron black holes, which was what I was working on at the moment. So I said, look, I've always been interested in giving a lecture on quantum mechanics, what a strange thing it is, and exactly what strange thing it is. And do you think such a lecture would be suitable? And he said, yes, give us a clever title. So I emailed back, quantum mechanics in your face, because I wanted to really confront people with quantum mechanics. And Peter said, no good, he said. A British audience would not understand the locution and indeed might think it was obscene. All to the good, I said, but he was adamant. So since one of the themes of the proposed lecture was that people get a lot of confusion because they keep trying to think of quantum mechanics as classical mechanics, I suggested this alternative title. And he said, I have all of this on disc. This is a true story. He said, this is, nope, a British audience wouldn't get it, too American. So I said, well, all right. If you want something British, he said, too facetious. So finally, we settled on this title, which, as you can see, is a little wimpier than the others. But now I'm back in the land of free speech, so the title of the talk is Quantum Mechanics in Your Face. Now, the talk will fall into three parts. There will be a preliminary, where I give a quick review of quantum mechanics. I would say it was the Copenhagen interpretation or the interpretation in somebody's textbook, but it's not really that. It's looser and more sloppy. Architectural historians, when they're discussing the kinds of buildings that were being built in a certain place in a certain time, but they aren't in any particular well-defined style, it's just what builders threw up in the United States circa 1948. They call it vernacular architecture, and this will be a quick review of vernacular quantum mechanics. That's more to establish notation and make sure we're all on the same wavelength. Then the two main parts of the lecture will be firstly a review of a improvement, a pedagogical improvement on John Bell's famous analysis of hidden variables in quantum mechanics, which is in fact easier to explain than Bell's original argument and deserves to be widely publicized. It was built by David Mermin, that's the M, out of some earlier work by Greenberger, Horn, and Zeilinger. Then the second part of the lecture, I will turn to the much vexed question of the sometimes called the interpretation of quantum mechanics, although, as I will argue, that's really a bad name for it. I want to stress that I have made no original contributions to this subject. There's nothing I will say in this lecture, with the exception of the carefully prepared spontaneous jokes. There is nothing I will say in this lecture, that was one of them. There's nothing I will say in this lecture that cannot be found in the literature. Of course, such is the nature of this subject that there is nothing I will say where the contradiction cannot also be found in the literature. So I claim a measure of responsibility, if no credit, the reverse of the usual scholarly procedure. Now, also, I will stick strictly to quantum mechanics in flat space and not worry about either classical or quantum gravity. We'll have problems enough keeping things straight there without worrying about what happens when the geometry of space-time is itself a quantum variable. Now, to begin with a very quick review, these transparencies are going to go by extremely fast. A pointer might be handy.
There's a laser pointer just to the right, Sidney, of the view graph.
Oh, view graph. Right. Okay. Got it. I'm always worried about these things. I'll point them the wrong way and zap a member of the audience. However, got it the right way. The state of a physical system is at a fixed time is a vector in Hilbert space. Following Dirac, we call it psi, normalized to unit norm. It evolves in time according to the Schrödinger equation, where the Hamiltonian is some self-adjoint linear operator. A simple one if we're talking about a single atom, a complicated one if we're talking about a quantum field theory. Now, if there is anyone who has any questions about the material on the screen at this moment, please leave the auditorium, because you won't be able to understand anything else in the lecture. Now, some, maybe all, self-adjoint operators are observables, in quotes. If the state is an eigenstate of an observable, capital A, with eigenvalue little a, then we say the value of A is big A is certain to be little a. Now, strictly speaking, this is just a definition of what I mean by observable and observed. But of course, that's like because those words have not occurred on any previous transparency, so I can call them, use what I want. But of course, that's like saying Newton's second law, F equals ma, as it appears in textbooks on mechanics, is just a definition of what you mean by force. Of course, that's true, strictly speaking, but we live but in a landscape. There is an implicit promise that when someone writes that down, when they begin talking about particular dynamical systems, they will give laws for force, not say for some quantity involving the 17th time derivative of the position. Likewise, the words observable and observed have a history before quantum mechanics. People like to say classical, all these things have a meaning in classical mechanics and we need a classical level. But really, it goes way earlier than classical mechanics. I'm sure the pre-Columbian inhabitants of Massachusetts were capable of saying in their language, "I observe a deer," and despite their scanty knowledge of Newtonian mechanics. And indeed, I even suspect that the deer was capable of observing the Native Americans, despite its even weaker grasp on action and angle variables. There's an implicit promise in here that when you put the whole theory together and start calculating things, these words observe and observable will correspond to entities that act in the same way as those entities do in the language of everyday speech under the circumstances in which the language of everyday speech is applicable. Now, to show that is a long story and not something I'm going to focus on here, involving things like the WKB approximation and von Neumann's analysis of an ideal measuring device, but I just wanted to point out that that's there. Now we come to the fourth thing. Every measure, what happens when the state psi is not an eigenstate of the observable A? Have I pointed this the wrong way? Yeah. Every measurement of A yields one of the eigenvalues. The probability of finding a particular eigenvalue, little a, is proportional to the magnitude of the part of the wave function that lies on the subspace of states with eigenvalue, little a. I'm assuming here, just for notational simplicity, that the eigenvalue spectrum is discrete. If little a has been measured, then the state of the system after the measurement is just that part of the wave function. All the rest of it has been annihilated. And of course, it has to be rescaled, or being a quantum field theorist, I should say, I suppose, renormalized to have it so it has unit norm again. This is the famous projection postulate. It is very different from the previous three things I have put, or sometimes called the reduction of the wave packet. It's very different from the previous three statements I've put on the board because it contradicts one of them, causal time evolution according to Schrödinger's equation. Schrödinger's equation, d psi dt is minus I h psi, is totally causal. Given the initial wave function, given the initial state of the system, the final state is completely determined. Furthermore, this causality is time reversal invariant. Given the final state, the initial state is completely determined. This operation is something other than Schrödinger's equation. It is not deterministic, it is probabilistic, and it is, you cannot, not only can you not predict the future from the past, even when you know the future, you don't know what the past was. If I measure an electron and discover it is an eigenstate of sigma z with sigma z equals +1, I have no way of knowing what its initial state was. Maybe it was sigma z equals +1, maybe it was sigma x equals +1, and it turned out I was in the branch that got the 50% probability of measuring sigma z up. Now, that ends the preliminary. Howard, I don't want to run too much over time. Of course, everyone makes this statement. But I started, what, a quarter after? OK. So before I go into the first of the two main parts of the lecture, the Ghcm analysis, are there any questions about this? OK. I will, in part two, return very much to a critical analysis of the reduction of the wave packet. But for the first part of this lecture, I'd like to take it as given. Now, there's references, but actually I call them credits because I notice nobody ever writes down the references. It's just here to avoid the speaker being sued. This whole analysis, as everyone knows, starts with the work of Einstein, Rosen, and Podolsky, which sat around as an irritant for some years until John Bell, picking up an idea from David Bohm, was able to turn it into a conclusive argument against hidden variables. A pedagogical improvement was made by David Merman, who, at least to my mind at least, really clarified what was going on in Bell's analysis. And then a completely different experiment was suggested by Greenberger, Horn, and Zeilinger. I've got a reference here to a paper they wrote with Abner Shimoni, not because that was the original paper, but the original paper is a brief report in the conference proceedings, and this on that one, polishing it up, and it's my version of Merman's version of Greenberger, Horn, and Zeilinger's Gedanken experiment inspired by John Bell's, based on Bohm and Einstein, Rosen, and Podolsky. And I've left out 90% of the references that you're going to see now. Now, the way I like to think of this analysis as imagining is by imagining a physicist whom I call Dr. Die-Hard, who was around at the time of the discovery of quantum mechanics in the late 20s and didn't believe it. And although some time has passed through then, he's still around, quite old, but intellectually vigorous, and he still doesn't believe in it. Our task is to convince him that quantum mechanics is right and classical ideas are wrong, or even, as I'll say, primitive, pre-classical ideas. Now, there's no point in trying to wow him with the anomalous magnetic moment of the electron or the behavior of artificial atoms that we just heard about or anything like that, because he is so deep down opposed to quantum mechanics and so old and stubborn that as soon as you start putting a particular quantum mechanical equation on the board, his brain turns off, rather like my brain in a seminar on string theory. So the only way to convince him is on very general grounds, not by doing particular calculations. So at first thought, you say it's easy. Quantum mechanics is probabilistic. Classical mechanics is deterministic. If I have that electron in an eigenstate of sigma x and choose to measure sigma z, I can't tell whether I'm going to get +1 or -1. There's no way anyone can tell. That's very different from classical mechanics, and it seems to describe the real world. Well, Dr. Die-Hard is not convinced for a second by that. He says probability has nothing to do with this fancy quantum mechanics. Jérôme Cardin was writing down the rules of probability when he analyzed games of chance in the late Renaissance. Okay. When I flip a coin or go to Las Vegas and have a spin on the roulette wheel, the results seem to be perfectly probabilistic, but I don't see any Planck's constant playing any significant role there, it says. It's just like that. The reason the roulette wheel gives me a probabilistic result is that there are all sorts of sensitive initial conditions which I can't measure well enough, initial conditions to which the final state of the ball is sensitive. There are all sorts of degrees of freedom of the system which I cannot control, and because of my ignorance, not because of any fundamental physics, I get a probabilistic result. This is sometimes called the hidden variable position. Really, you don't know everything about this state of the electron when you measure its momentum and its spin along the x-axis. There are zillions of unknown hidden variables which you can't control, and maybe also in the system that is measuring the electron. There's no separation in this viewpoint between observing system and quantity being observed. And you get a probabilistic, if you knew those quantities exactly, then you know exactly what the electron was going to do in any future experiment. But since you only know them probabilistically, you only have a probabilistic distribution. And here I've written it down in the somewhat fancy-schmancy mathematical notation, but the words are there. Well, in fact, this is right. You can get probability from classical mechanics. And John von Neumann, way back, was aware of this and said, no, that's not the real difference between classical mechanics and quantum mechanics. The real difference is in that in quantum mechanics, you have non-commuting observables. If you measure sigma x repeatedly for an electron and take care to keep it isolated from the external world, you'll always get the same result. But if you then measure sigma z and get a probabilistic result, when you measure sigma x again, you will again get a probabilistic result the first time. The measurement of sigma z has interfered with the measurement of sigma x. And that's because you have non-commuting observables, and those are characteristic of quantum mechanics. And Dr. Die-Hard says, absolute nonsense. We're big, clumsy guys, and when we think we're doing a nice, clean measurement of sigma x, we might be messing up all of those hidden observables. And then when we try and measure sigma z, we get a different result because we've messed things up. My friends, the anthropologists, talk about a lot when they discuss how an anthropologist can affect an isolated society he or she believes he's observing. Okay? For some reason I don't understand, they call it the uncertainty principle. And Dr. Diehard continues to say, my friends, the social psychologists, tell me that if you do an opinion survey, unless you construct it very carefully, the answers you will get to the questions will depend upon the order in which they are asked. This is true, by the way. And he doesn't see any difference between that and measurements of sigma x and sigma z. Now, thus Dr. Diehard's position. And as John Bell pointed out in the first written of those two articles I cited, which is not the one with the famous inequality, this is in fact an irrefutable position, despite all the stuff to the contrary that has been said on the literature. On this level, there is no way of refuting it. And he gave a specific example of a classical theory that on this level reproduced all the results of quantum mechanics, the de Broglie-Bohm pilot wave theory. However, if Dr. Diehard admits one more thing, we can trap him. And I will now explain what that one thing is. Here we have a drawing of space and time. Space-time. It's really four-dimensional, but due to budgetary constraints, I've had to represent it as a two-dimensional object. The scale has been chosen so that time is measured in years and x in light years, and therefore the paths of light rays are 45-degree lines. Now let's consider two measurements on possibly two different systems done in two regions, A and B. Forget B prime for the moment. That its role will emerge later. So these black dots represent actually substantial, well, you can see from the scale, substantial regions in space-time during which an experiment has been conducted. Now, one thing Dr. Diehard will have to admit is that although the results of an experiment in A may interfere with an experiment in B, the results of an experiment in B can hardly interfere with the results of an experiment in A unless information can travel backwards in time, which we will assume he does not accept. Okay? That's because A is over and done with and its results recorded in the logbook before B occurs. On the other hand, if we imagine another Lorentz observer with another coordinate system, B would appear as B prime here. B and B prime, as you can see by eyeball, are on the same space-like hyperbola. There is a Lorentz transformation that leaves A at the origin of coordinates unchanged and turns B into B prime. B is space-like separated from A. Light signal cannot get from A to B. And nothing traveling slower than the speed of light can get from A to B. Now, that second Lorentz observer would give the same argument I gave, except he would interchange the roles of A and B prime. He would say the results of an experiment at A cannot interfere, the act of doing an experiment at A cannot interfere with the results of an experiment at B prime because B prime is earlier than A. But B prime is B, just B seen by a different observer. Therefore, if you believe in the principle of Lorentz invariance, and if you believe you cannot send information backwards in time, you have to conclude that experiments done at space-like separated locations sufficiently far apart from each other at space-like separated locations cannot interfere with each other. It can't matter what order you ask the questions if this question is being asked of an Earthman and this one of an inhabitant of the Andromeda Nebula. And they're both being asked today. Are there any questions about this? This is the groundwork from which the rest of the thing will proceed. So everything else, we accept the Diehard position. Now, here is the experimental proposal. This is a drawing from an imaginary proposal to the Department of Energy. Okay. for the die-hard experiment. Three of Dr. Die-Hard's graduate students are each assigned to an experimental station. As you see from the scale, they are several light minutes from each other. The graduate students with a lack of imagination are called numbers 1, 2, and 3. Okay, they're almost as old as Dr. Die-Hard. It's difficult to get a thesis under him. Okay. They're informed that once a minute, something will be sent from a mysterious central station to the three die-hard teams, to each of the three die-hard teams. What something is, they don't know. However, they're armed with measuring devices, again, whose structure they do not know. They are called dual cryptometers because they can measure each of two things, but what those two things are, nobody knows. At least the diehards don't know. They can turn a switch to either measure A or measure B. They do this decision once a minute, shortly before the announced time of the signal, and sure enough, a light bulb lights up that says either A is +1 or A is -1 if they are measuring A as shown, or the same thing for B. They have no idea what A or B is. It's possible the central station is sending them elementary particles. It's possible the central station is sending them blood samples, which they have the choice of analyzing for either high blood cholesterol or high blood glucose. It is possible the whole thing is a hoax. There is no central station, and a small digital computer inside the cryptometer is making the lights go on and off. Okay? They do not know. Okay? Now, in this way, however, they obtain a sequence of measurements which they record as this. This means observer 1 has decided to measure A and obtain the result +1. Observer B 2 has decided to measure B and obtain the result -1. Observer 3 has decided to measure B and obtain the result -1. And they obtain in this way zillions of measurements on a long tape. They record them in this way because they really believe whatever this thing is doing, A1 is 1. That is to say, the value of quantity A that would be measured at station 1 is 1, independent of what is going on station 2 and 3, because these three measurements are space-like separated. Okay? That's what they have to believe if they're diehards. They have to believe there's really some predictable value of this thing which they would know if they knew all the hidden variables. And in this particular case, they don't know what B1 is, but they know what A1 is. Now, as they go through their measurements, they find in that roughly 1/8 of the measurements, they're making random decisions in which they do measure things. Whenever they measure 1A and 2Bs, the result is +1. Now, since they're making their choices at random, and since they believe that these things have well-defined meanings independent of their measurements, they have to believe, if they believe in normal empirical principles, that when all the time the value of 1A and 2Bs, the value that would be obtained if they had done the measurement, the product is +1. Sometimes all three of these numbers are +1. Sometimes one of them is +1 and two are -1, but the product is always +1. It's as if I gave you a zillion coins and you turned up 1/8 of them, a zillion boxes, and you opened up 1/8 of them and discovered each of them had a penny in it. It would be, you assume, within 1/(n), negligible error, that if you opened up all the other boxes, they would also have pennies in them. Whenever they look, this is 1. Now, by the miracle of modern arithmetic, that is to say, by multiplying these three numbers together and using the fact that each b² is 1, they deduce that if they look on their tape for those experiments in which they've chosen to measure the product of three A's, they would obtain the answer +1. Now, let's look behind the scenes and see what's actually going on. This maybe a little suspense would help, so I will behind the scenes. Well, it's not blood samples we're sending to them after all. It's 3 spin-1/2 particles arranged in the following peculiar initial state: 1 over the square root of 2 all spins up minus all spins down. What A and B are simply sigma x. For the A is simply sigma x for the particle that arrives at the appropriate station, and B is sigma y. Let's first check that A1, B2, B3 acting on this state size plus 1. Therefore, by the third statement about quantum mechanics I put on the board in my preliminary section, this quantity is definitely always going to be measured to the plus 1. Well, that's sigma x1, sigma y2, sigma y3 by my transcription table. Sigma x turns up and to down. Sigma y also turns up and to down with a factor of I, or maybe minus I. I can never remember, but that's no problem here because you've got 2 of them, so the square is minus 1. So therefore, acting on the first part of this component of this state, this operator reproduces the second component, including the minus sign, and acting on the second component, it reproduces the first. So this state is indeed an eigenstate with eigenvalue plus 1. And of course, since everything is permutation invariant, the same thing is true for the other 2 operators. But A1, A2, A3 is sigma x1, sigma x2, sigma x3. And each of the 3 sigma x's turns an up and to a down without a minus sign. Therefore, this state is also an eigenstate of A1, A2, A3, but with eigenvalue minus 1. The diehards, using only these proto-classical ideas, they aren't even so well developed as to be called classical physics. They're sort of the underpinnings of classical reasoning, deduce that they will always get A1, A2, A3 times 3 plus 1, sometimes a plus 1 and 2 minus 1s, but always plus 1. In fact, if quantum mechanics is right, they will always get minus 1. Okay? This is pedagogically superior to the original Bell argument for 2 reasons. Firstly, it doesn't involve correlation coefficients. It's not that classical mechanics says this will happen 47% of the time and quantum mechanics says it happens 33%. Okay? Secondly, it is easy to remember. Whenever I lecture on the Bell inequality, I have to look it up again because I can never remember the derivation. Okay? This thing, you see, the ingredients in it are so simple that if someone awakens you in the middle of the night 4 years from now and puts a gun to your head and says, show me the Ghcm argument, you should be able to do it. Yeah. Okay, now, this is, what we have shown is that there are quantum mechanical experiments where the conclusions cannot be explained by classical mechanics, even the most general sense of classical mechanics, without assuming unless, of course, the classical mechanical person is willing to assume transmission of information faster than the speed of light, which with the relativity principle is tantamount to transmission of information backwards in time. Now, this is, of course, also John Bell's conclusion, and this is, I must say, much misrepresented in the popular literature, and even some not so popular literature. That's not coming out right. I mean some technical literature, where people talk about quantum mechanics necessarily implying connections between space-like separated regions of space and time. That's getting it absolutely backwards. There are no connections between space-like separated regions of space and time in this experiment. In fact, there's no interaction Hamiltonian, let alone one that transmits information faster than the speed of light, except maybe an interaction Hamiltonian between the individual cryptometers and the particles. But otherwise, okay, it's either quantum mechanics or superluminal transmission of information, not both. Why on earth do people, and now here I'm trying to see inside other people's heads, which is always a dangerous operation, but let me do it. Why on earth do people get so messed up about, so confused, so wrong about such a simple point? Okay. Why they write long books about quantum mechanics and non-locality, full of funny arrows pointing in different directions? Okay. That's the technical philosophers. They really, well, I'll avoid the laws of libel. So anyway, why do they do this? It's because I think secretly, in their heart of hearts, they believe it's really classical mechanics. We're really putting something over on them. Deep, deep down, it's really classical mechanics. Yeah.
Isn't part of this whole experiment premised on the assumption that there exists, that all of these instruments are outside the light cones of each other, all of the measuring instruments are outside the light cones?
Yeah.
And so you feel that if that premise were false, then that wouldn't
No, I mean, I've explained what's happening. Okay, any student who's taken a freshman course on quantum mechanics and knows what spin is can explain what's happening. I'm saying if they're outside the light cones of each other, there is no conceivable classical mechanical explanation. Okay? If they're just far from each other but not outside the light cones of each other, you might say there is no plausible classical mechanical explanation. But here, this way, there is no logically possible classical explanation. Okay, I will, because we're somewhat squeezed for time, I'd be happy to talk about this at greater length later. Now, people get things backwards, and they shouldn't. It has been said, and wisely said, that every successful physical theory swallows its predecessors alive. By that we mean that in the appropriate domain, well, for example, the way statistical mechanics swallowed thermodynamics. In the appropriate domain of experience, the concepts of the fundamental concepts of thermodynamics, entropy, for example, or heat, were explained in terms of, heat was explained in terms of molecular motion. And then we showed that if you defined heat in terms of molecular motion, that acted under appropriate conditions pretty much the way heat acted in thermodynamics. It's not the other way around. The thing you want to do is not interpret the old theory in terms of the new theory in terms of the old, but the old theory in terms of the new. The other day I was looking at a British videotape of Feynman explaining elementary concepts in science to an interrogator whom I think was the producer of the series, Christopher Sykes, although he wasn't identified and was off screen. And he asked Feynman to explain the force between magnets. And Feynman hemmed and hawed for a while, actually, and then he got on the right track, and he said something that's dead on the nail. He said, you've got it all backwards, because you're not asking me to explain the force between the seat of your pants and the seat of a chair. You want me, when you say to explain the force between magnets, to explain the force in terms of the kinds of forces you think of as being fundamental, those between bodies and contact. Obviously, I'm not phrasing it as wonderfully as Feynman would, but well, as Picasso said in another circumstance, it doesn't have to be a masterpiece for you to get the idea. Anyway, whereupon, as we physicists all know, it's the other way around. The fundamental force between atoms is the electromagnetic force, which does fall off as 1 over r squared. The idea is, where Christopher Sykes was confused, is that he was asking something impossible to explain the pants chair force in terms of the force between magnets. The right thing to do, got it backwards. What he should have been asking for is that. What he was asking for is something impossible to explain the fundamental quantity in terms of the derived one. Likewise, a similar error is being made here. The problem is not the interpretation of quantum mechanics. That's getting things just backwards. The problem is the interpretation of classical mechanics. Now, I'm going to address this, and in particular, the famous or infamous projection postulate now. The fundamental analysis is von Neumann. I don't read 2 words of German, but I wanted to put down the early publication. I read it in English translation. The position I am going to advocate is associated with Hugh Everett in a classic paper, and some of the things I'll say about probability later come from a paper by Jim Hartle and one by Cambridge's own Eddie Farhi, Jeffrey Goldstone, and Sam Gutman. Now, I'd like to begin by recapitulating von Neumann's analysis of the measurement chain. I prepare an electron in a sigma x eigenstate, and I measure sigma z. The famous non-deterministic reduction of the wave packet takes place, and with equal probabilities, I cannot tell which the spin either goes up or down. But this is rather unrealistic, even for a highly idealized measurement. An electron is a little tiny thing, and I have bad eyes. I probably won't be able to see directly what its spin is. There has to be an intervening measuring device. So we complicate the system. The initial state is the same as before as far as the electron, but the measuring device is in some neutral state. The electron interacts with the measuring device. Von Neumann showed us how to set things up. So that's with the interaction Hamiltonian. So if the electron is spinning up, the measuring device goes, maybe it's one of those dual cryptometers. The light bulb saying plus flashes. If the electron is spinning down, the light bulb saying down flashes. Then the system, this is normal deterministic time evolution according to Schrödinger's equation. Now I come by, I can't see the electron, but I observe the device. By the usual projection postulate, I either see it in state plus or state minus. I make the observation. If I see it in state plus, the rest of the wave function is annihilated, crossed out. I get with equal probabilities these 2 things, and the result is the same as before because the electron is entangled with the device. I measure the device, the electron comes along for the ride. Now let's complicate things a bit. Let's suppose, however, I cannot do the measurement because I'm giving this lecture. However, I have a colleague, a very clever experimentalist, for purpose of definiteness, let's say it's Paul Horowitz, who has constructed an ingenious robot. I'll call him Gort. It's a good name for a robot. He's constructed this robot, and I say, Gort, I want you during the lecture to go and see what the measuring device says about the electron. And so Gort comes and does this. And of course, although he's an extremely ingenious and complicated robot, he's still just a big quantum mechanical system like anything else. And he has so it's the same story. Thing starts out with electron up, measuring device neutral, a certain register and a RAM chip inside Gort's belly. Also, it has nothing written on it. Then everything interacts. And the state of this world is electron up, measuring device says up, Gort's RAM chip's register says up, plus the same thing with up replaced by down, all divided by the square root of 2. And Gort comes rolling in the door there on his rollers, and I say, hey, Gort, which way is the electron spinning? And he tells me in whammo, either goes into one or the other of these states, 50% probability. But Gort is very polite. He observes that I am lecturing. So rather than coming to me directly, he rolls up to my colleague, Professor Nelson, sitting there in the corner, and hands him a slip of printout. Says, pass this on, says either up or down. Pass this on to Sidney when the lecture is over. And he rolls away. Well, of course, vitalism was an intellectually live position in the 19th century, early 19th century. Dr. Lydgate in Middlemarch, which will be appearing on TV tomorrow, hold it, that living creatures are not simply complicated mechanical systems, but it hasn't had many advocates this century. And I think most of us would admit that David is just another quantum mechanical system, another quantum mechanical system. although perhaps more complicated than the electron and Gort, and certainly more likable. But anyway, there he is. So it's the same story as before. The state of the world after all this has happened is electron up, measuring device says up, Gort's RAM chip says up, Davis slip of paper says mind has thought in it up. Okay. Plus the same thing with down divided by square root of 2. After the lecture, I go up to him and say, "What's up, David?" Whammo. He tells me, and the whole wave function collapses. Now this is getting a little silly. And especially if you consider the possibility that after all, I'm getting on in years, I'm not in perfect health, here I am running around a lot. Maybe I have a heart attack before the lecture is over and die. What happens then? Who reduces the wave packet? Now, this was also actually Yakir Aharonov, who of course since acquired great fame for himself, was a young postdoc at Brandeis when I was a young postdoc at Harvard. And I had been reading von Neumann and thinking about this and come to a conclusion which I did not like, that, which was solipsism. I was the only creature in the world that could reduce wave packets. Otherwise, it didn't make sense. I was not totally happy with this position, even though I was as egotistical as any young man, indeed probably more egotistical than most. I was still unhappy with the position, and I was discussing this with Aharonov. Now, even in his youth, he would smoke these enormous cigars, which he would use to punctuate the conversation. He would take huge drafts on them. He was and is sort of the quantum George Burns. Anyway, anyway, I explained this position to him, and he said, "I see. Tell me, before you were born, could your father reduce wave packets?" Now, I will argue that, in fact, there is no special measurement process. There is no reduction of the wave function in quantum mechanics. There is no indeterminacy and nothing probabilistic. Only deterministic evolution according to Schrödinger's equation. This is not a novel position. In the famous paper on the cat, Schrödinger raised this position, and instantly that the cat is in fact in the coherent superposition of being dead and being alive, and said, ridiculous. So ridiculous. We reject the ridiculous possibility. Some years later, in the paper on Wigner's friend, where Wigner attempted to resolve the ancient mind-body problem through the quantum theory of measurement, he also raised this position and said it was absurd. There's a recent paper by Zurich in Physics Today. Zurich has made major contributions to the theory of decoherence, and where he actually, instead of just saying it's ridiculous or absurd, he actually raised a question one can talk about. He said, if this is so, why do I, the observer, perceive only one of the outcomes? This is now the question I will attempt to address, Zurich's question. If there is no reduction of the wave packet, why do I feel at the end of the day that I have observed a definite outcome, that the electron is spinning up or the electron is spinning down? In order to ease into this, I'd like to begin with an analysis of Neville Mott's. Neville Mott worried about, way back when in 1930, about cloud chambers. He said, look, I have an atom releases an ionizing particle at the center of a cloud chamber in an S wave. And it makes a straight line track. Why should it make a straight line track? If I think about an S wave, it's spherically symmetric. Why don't I get some spherically symmetric random distribution of sprinkles? Why should the track be a straight line? Now, we're going to answer that question in a faster and slicker way than Neville Mott did, although we have the advantage, of course, of 64 years of hindsight. And we must assume that the scattering between the particle and an atom, when it ionizes it, is unchanged, or changed only within some small angle to begin with. Otherwise, of course, even classically, the particle would bounce around like a pinball on a pinball table. Let C be the state of the cloud chamber. we define a linearity operator L, a projection operator, so that L on C equals C if there is a track and if it forms a straight line to within some small angle, and L on C equals 0 if the track is not a straight line, or if there is no track for that matter. Now, let's imagine we start out the problem in some initial state where the particle is concentrated near the center of the position and near some momentum k. And the cloud chamber is in a neutral condition, all ionized, ready to make unionized, ready to make tracks. This evolves into some final state. Now, we all believe that if you started out the particle in a narrow beam, it would, of course, make a straight line track along that beam. The final state would be an eigenstate of this. There would be a track. It would be an eigenstate of the linearity operator, and it would have eigenvalue plus 1. Now, here comes the tricky part. Not tricky to follow, but tricky clever. I consider an initial state that's an integral over the angles of k of this state. This is a state where the particle is initially in an S wave and the cloud chamber is still in a neutral state. That's independent of k. That evolves by the linearity, the causal linearity of Schrodinger's equation, into the corresponding superposition of these final states here. But if I have a linear superposition of eigenstates of the particle of the operator L, each of which is an eigenvalue with eigenstate with eigenvalue plus 1, then the combination is also an eigenstate with eigenvalue plus 1. So this also has straight line tracks in it. That's the short version of Mott's argument. Mott said, the problem is that people think of the Schrodinger equation as a wave in a three-dimensional space rather than a wave in a multi-dimensional space. I would phrase that, making a gloss on this. He's dead, so I can't check whether it's an accurate phrasing. I would make a gloss on this and say the problem is that people think of the particles of quantum mechanical system, but the cloud chamber as a classical mechanical system. If you're willing to realize that both the particle and the cloud chamber are part of two parts of interacting parts of one quantum mechanical system, then there's no problem. It's an S wave not because the tracks are not straight lines, but because there is a rotationally invariant correlation between the momentum of the particle and where the straight line points. But it's always an eigenstate of this linearity operator. Any questions about this? Okay, nobody doubts it. The tracks in cloud chambers or bubble chambers, if you're young enough, the tracks in cloud chambers or bubble chambers are straight lines, even if the initial state is an S wave. Now, I will now give an argument due to David Albert, now return to Zurich's question. We must assume, of course, Zurich asks, why do I always have the perception that I have observed a definite outcome? Okay. Now, to answer this question, no cheating. We can't assume Zurich is some vitalistic spirit loaded with élan vital, unobeying the laws of quantum mechanics. We have to say the observer, well, I don't want to make it Zurich, that's using him without his permission. I'll make it me, Sidney, has some Hilbert space of states. And some condition in Sidney's consciousness corresponds to the perception that he has observed a definite outcome. So there's some projection operator on it, the definiteness operator. Okay? If you want, we could give it an operational definition. If the definite state where the definiteness operator is plus 1 is one where a hypothetical polite interrogator asks Sidney, have you observed a definite outcome? And he says yes. In the orthogonal states, he would say, no, gee, I was looking someplace else when that sign flashed on, or I forgot, or don't bother me, man, I'm stoned out of my mind, or any of those things. Okay. Now, let's begin our same old system as before, electron measuring apparatus and Sidney, now we've added. And it goes into, if the electron is spinning up, the measuring apparatus measures spin in the up direction. We get a definite state, no problem of superposition. And Sidney thinks I've observed a definite outcome. Measurement is up. Also if everything is down. Okay. Well, now what if we start out with a superposition? Same story as Neville-Mott's cloud chamber. If this is the same reason the cloud chamber always observes the track to be a straight line, Sidney always has the feeling he's observed a definite outcome. Okay. I have given this, as you can see, there was an A in the corner here.
Which one was the outcome?
No. Yeah. No, that's not what Zurich said. Zurich didn't say it's a matter of common experience that in this experiment we always observe the electron spinning up. And Neville-Mott didn't say it's a matter of common experience that in the cloud chamber the straight line is always pointing along the z-axis. Okay. The matter of common experience is that Sidney always has the perception that he has observed a definite outcome if you set up the initial conditions correctly. The matter of common experience is that the cloud chamber is always in a straight line. If you don't like this argument, you can't like this one. If you like this one, you have to like this one. Okay. The problem here, the confusion Neville-Mott removed, was refusing to think of the cloud chamber as a quantum mechanical system. The problem here is refusing to think of Sidney as a quantum mechanical system. Because of the pressure of time, I will remove these transparencies now and go on to discuss the question of probability. Yes. Probability is a difficult question to discuss because it requires, from the word go, I will get this done in the 7 minutes remaining, that we look at something contrafactual. If I ask whether a given sequence is or is not random, I can't do that even in classical probability theory for a finite sequence. For example, if I consider a binary sequence where the entries are either 1 or -1, I say, is the sequence 1 a random sequence? Obviously, no way of answering that question. And for a sequence of an Avogadro number of digits, it's logically no easier. But if I have an infinite sequence, I can ask whether it's random. And let me talk about that. Let me suppose I have an infinite sequence of pluses and minus ones, which I might think represent heads and tails, and I want to see if these sequences can be interpreted as a fair coin flip. Well, firstly, I'd want the average value of this quantity, sigma r, which is, of course, simply the limit of the average value of the first n terms as n goes to infinity to converge to 0. Also, if I were an experimenter, I would probably look at correlations. I would take the rth value of sigma times the r plus 8th value of sigma for some value of a, look at the limit of this correlation, and ask that this quantity be also 0 for any value of a. Okay? That way I could reject sequences like 1, 1, minus 1, minus 1, 1, 1, minus 1, minus 1, which nobody would call random. And I could also look for triple and higher correlations. And if all of those things were 0, then I'd say there's a pretty good chance there's a random sequence. Actually, I would be sloppy in the way experimenters are sloppy. I would actually have to provide even further tests if I wanted the real definition of randomness, the Martin Love definition of randomness. But this will be good enough for a lecture where I only have 5 minutes left. Okay. We'll see how this one works. Now, we want to ask the parallel question in quantum mechanics. We start out with an electron in a state I'll call sidewise. Just our good old sigma x eigenstate, the same state I've used before. I consider an infinite sequence of electrons heading towards my measuring apparatus. And I do the usual routine with the measuring system in Sidney's head and turn it into a sequence of memories in Sidney's head, or maybe Sidney has a notebook and he writes down +1, -1, +1, -1. And I obtain a sequence of records correlated with the x component of spin. Sorry, with the z component of spin. The sigma z measuring device. And I ask, does this observer observe this as a random sequence? That is to say, is this state here an eigenstate of the corresponding quantum observables with eigenvalue 0. Well, we know it's all connected with, all correlated with sigma z, so in order to keep the transparency from overflowing its boundaries, I just looked at sigma z rather than the operator for the records. I defined the average value of sigma z as exactly the same way it's done up here. And then I say, is this an eigenstate of this operator with eigenvalue 0? If it is, we can say the average, despite the fact that there's nothing probabilistic in here, we can say that the average value of sigma z is guaranteed to be observed to be 0. Well, the calculation is sort of trivial. Let's compute the norm of this state obtained by applying the state obtained by applying this operator to this state. Well, it's two sums, and here I've written them out. Each of them is an individual thing. There's a 1 over n squared, there's a sum on R, and a sum on S. Now, in this particular state, of course, if R is not equal to S, this, quote, expectation value is equal to 0, because you get just the product of the independent expectation values, which are individually 0. On the other hand, if R is equal to S, then this is sigma z squared, which we all know is plus 1. Therefore, the limit of this thing up here is the limit of 1 over n squared. The double sum collapses to a single sum. Only the terms with R equals S contribute. And each entry with R equals S contributes 1, so you get n. Thus, the result is n over n squared, which is, of course, 0. And of course, the same thing happens for all those correlators, because for each one is a sum of terms with a 1 over n in front, and only the entries that match perfectly will give you a non-zero contribution. So, this definite quantum mechanical state, completely determined by the initial conditions, okay, is nevertheless matches this experimenter, also considered as a quantum mechanical system, definition of randomness. Okay? Something that would be impossible in classical mechanics, but it's quantum mechanics, stupid. Now, one final remark. In Tom Stopper's play Jumpers, there's an anecdote about the philosopher Ludwig Wittgenstein. I have no idea whether it's a real story or a Cambridge folk story. Anyway, it goes like this. A friend is walking down the street in Cambridge and sees Wittgenstein in a corner, standing on a street corner, lost in thought. Says, "What's bothering you, Ludwig?" And Wittgenstein says, "I was just wondering why people said it was natural to believe the sun went around the earth rather than the other way around." And the friend says, "What? Why? That's because it looks like the sun goes around the earth." And Wittgenstein thinks for a moment and he says, "Tell me, what would it have looked like if it had looked like it was the other way around?" Now, people say the reduction of the wave packet occurs because it looks like the reduction of the wave packet occurs. And that is indeed true. What I'm asking you in the second main part of this lecture is to consider seriously what it would look like if it were the other way around, if all that ever happened were causal evolution according to quantum mechanics. And what I have tried to convince you is that what it looks like is ordinary everyday life. Welcome home. Thank you for your patience.
Any quick questions before lunch?
One of the other things that's mentioned in the projection option is that at immediate measurement, after the measure would yield the same measurement.
That's right.
What you showed is that the wave function is an eigenfunction of the depth number, meaning it's a linear combination. It didn't say. Where does that other part come in?
Well, that comes into the structure of the Hamiltonian, of course. While you have to talk about von Neumann's definition of a measurement, which involves the coupling of the measuring apparatus to the system, but if you make one of these idealized von Neumann measurements, which is essentially assuming that the interaction between the measuring apparatus and the system is governed by the sudden approximation, then you show that if you do two of them in sequence,
In other words, there's no time to evolve.
yeah, then you do two of them in sequence, both cryptometers will yield the same result. Okay, I can show you that in more detail if you wish.
You said in passing that you're a follower of Everett.
Yeah, but that's a tricky thing to say. That's like saying you're a Christian. I mean, Everett wrote this one truly wonderful paper, and then everyone got on their horse and rode off in all directions. The position I'm advocating is a position that, at least in my case, was certainly largely inspired by Everett's paper. Whether it's really Everett's position or not, I would prefer not to discuss.
Okay, if there are no further questions, we'll have a final word from Dr. Garrett.
I'd just like to take this opportunity on behalf of the New England section of the American Society, as well as my colleagues in the to thank the organizing committee here at Harvard for an outstanding job. I think we've all learned a great deal out of things that we thought we already understood. The organizing committee, of course, consisting of Howard Georgi, Eric Mazur, and Paul Bamberg. And I also think we should give a round of applause to Bonnie Courier, who did a lot of hard work in bringing things together. Let's thank
Okay, well, let's eat.
There we go. This is what you get when you come to my stream on Sidney Coleman Tuesdays. Feynman Thursdays. Feynman Friday, maybe. Maybe. We could do perturbation theory Friday and spell Friday with a PH. What does having money have to do with understanding quantum mechanics? Those two things are unrelated. Have I looked into Gwen's Lab Rat puzzle game? She sent me the trailer way back. I have not played it. To get into Harvard, I don't think you need money to get into Harvard. I think you need money to pay your tuition if you want to actually attend Harvard. Okay, we're not going to do any more Sidney Coleman for a while. So let's see where we are. Just got your beta. There's a beta key already. She just shipped her last game, man. Audio set time. Let's be consistent about the prefixes for a little bit. Oh, whoops. Keep changing that. I'll just fix whoever uses that. Yeah, that doesn't work very well. Okay. Okay. Read packets. Read packets. Demux get start time. Demux get duration. Okay. Whoa! Start code and packet type are the same? Or not? Hold on. What do we use type for? Yeah. Wait, what? Holy crap, dude. Yeah. These are the same as start codes. Dang it, bro. Is this supposed to be OXC3? God, dude, this web browser is so slow. I just turned up the size too big accidentally. Audio 4. This looks like a cut and pasticle error in the original thing. How is that not C3? That's just untested. How is the compiler supposed to know what all the errors are when it can't know the correct type of enough of your program due to other errors in order to correctly check those other parts of the program? Like, seriously, bro. Four is nothing. Why would four be nothing? Why would you define it if it was the same as three? Okay, you know what? We're going to put this in packet type. Bug it. Bug it. All these things that are start code are packet type. That's a start code. Where is start code defined? Is it in demux? This is the disadvantage of having all the files. Is it in video? Yeah. Okay, so now we have all the packet types. That's start code. We're going here, doing the same thing. Wanted start code given, dude, the start code, like what? I mean, was that? I wanted S32. I still don't know what the hell a start code is. That's okay. What is macro block address? I actually want to cast on the other side. Okay. So file tell and file seek we don't have. That's a goofy. All right, well, Zagita, why don't you write a compiler that does as much as this compiler, then you can come back and yell at me about error handling. All right? Because then you'll actually know what the issues are. You are actually asking for a magical compiler that you can read your mind if you're talking about misplacing a semicolon not being a problem. You have no idea, dude. All right. I was sort of inconsistent about when I took the prefixes off. That's coming back to bite me. Yeah. I like the lamp too. If Visual Studio can do it, why can't the language do it? Well, yeah. First of all, those are two very different situations. And secondly, it can't do it consistently, which is also why you don't want your programming language to do it. Were these supposed to be RI, GI, and BI? I guess so. Wait. Put pixel. No, that's actually, those are backticks. Synthesis window. What even is, oh, that's one of the tables. Is that actually 512? I guess so. What is U? What is this U? It's a 32. We should just call a 0 function on that. The mem set is not necessary. Let's just put the prefix on for now. We might take it off later. I don't know. Have a look at Teardown. I played Teardown on stream a while back for a little bit. I played the boat level. That was the last level that I played, was the boats and trucks and whatever, and stealing the cars. I don't know. I played that level. All right, I'm going to put back the buffer prefix. File size. Why do you want float 64? Why is seek pause? Okay, offset is like a float. All right, let's do this. All right. So packet start. Okay. What happened to default size? Really? All right. Fine. How would I rate Teardown? I don't know. I didn't play it super far. I don't like rating games anyway. Argument 1 doesn't match. Wanted pointer to PLM. When passing a procedure is callback. So buffer load callback I don't think this. Oh, I misdid buffer load callback. That's what's going on. Buffer load. Okay. Yes. It's definitely supposed to be 1, 2, 3, 4 sequentially because it does that. Ooh, we had a lot of selfs in there. Video decode block, loss of information. Why is that? Oh, yeah. I'm still not sure about this rule, like when they're really small integers and we make them S64. Maybe we should make them the smallest signed type that could fit both of those. That might be better. Okay, file open. Returns, oh, it returns a file by value. All right. Yeah. Okay, that's great. That's fine. That's going to screw some things up. Okay. understand why this was broken up this way, but all right. File length. File read. Well, we are down to just not having these functions. Let's pretend like we have these functions. There might be more errors after that. That's great. See, Sidney Coleman gives you powers. Now, I guarantee this won't actually work. I mean, there's nothing to run yet because it's just a folder, but and it definitely won't work because of the file stuff. Okay, guys, here's the question. My theory is maybe we don't want to support seek. Like, maybe that's stupid. And if you want to seek in a file, you should know where it should be. I will ask my friends about this. Of course, you would still need a read from offset. But I guess sequential reads do that. You think seek is non-trivial for video? What do you mean? What do you mean? If you don't have seek, how do you open a file and go to the position you want? I mean, maybe you supply the index of where you want to read from. I don't know. I always thought seek was stupid and a mess, but maybe we provide it for now and think more heavily about it later. Maybe there's no seek type. Like the whole like seek n bytes from the end stuff is bullshit. Like maybe we just say, give me the position in the file, right? The seek set and seek end and all that bull crap can jump off a cliff. Let's do that. Okay, so we're going to do the windows first. We're going to do file seek and file tell. I honestly don't know how to do that. Windows file seek. No, not seek API. Set file pointer, bro. Set file pointer X. I guess seeking forward is maybe okay. I don't know. I don't know. How long is it? I feel like the stream's been going for a while here on Sidney Coleman Tuesday. Yeah, we're doing good. Doing good. Our fruit packages are now done with. We get a wonderful snow mint now. Mm-mm. Mm-mm. A float from 0 to 1 representing where you are in the file. How do you convert that to the number of bytes to read? What would you use that for? The float version, I mean. So, guys, I think I want to pause here because the deal is I don't really know if I want to implement file seeking as the base API. Like on a modern system, especially all these SSDs and stuff that are happening, you kind of want to read non-sequentially and like just dispatch a bunch of like DMA windows and whatever if you want to read a file fast. And it doesn't look like the old Unix file API. However, of course, I am sympathetic to the argument that people kind of want this sometimes. So, I don't know. Float precision is pretty good between 1 and 0. Yeah, but why do you want to engage the FPU to know where in the file you are? And why would you use a float when your resolution is 1 byte resolution across the range? Why don't you just use an integer for that? Something like read file at. Yeah, I mean, I don't know. I don't know what to say about this. What are the cons of adding it to the base API? Because you sort of solidify the API around that. The pro is it's easier to port your shitty Unix software that reads files. The con is you get something less good. Now Jeff and Casey are talking all about file stuff, advanced file stuff. Maybe you want to read from tape at some point. You should know whether you're reading from tape or not. That's just how that works. Yeah, this is the file API that we sort of give people to program with. I guess for now we could provide that, but honestly, I feel like you're not going to want to use seeking later. Maybe we'll do it for now anyway. Let me get some green tea and we'll continue. I thought I was going to stop, but I am motivated to continue. how many green teas do I drink a day? Some multiple of Avogadro's numbers. Okay. Yeah, it does make porting harder. Maybe we should call this shitty Unix file, right? And then we could have like new good file or whatever. I don't know. Okay. We'll do it. So we're just going to do the same thing everyone always does. All right. All right, so set file pointer X. Do we have this, by the way? Set file pointer X. We do. Set file pointer X. I don't know, does it have a handle? Pause. Null. DW move method is going to be Windows type. And those are going to be sorry, I'm coughing. File begin. Okay, what did I just call mine? Beginning, current, and end. Great. Okay. And set file pointer X is non-zero or zero. Great. So file tell is going to be the following. Return true position. Right? Bool. Oh, I left this pasted in. Oh. Wait. What? Oh, in buffer. Start. Or did I call it beginning? Beginning. Let's go start, because I think that's just more in common. Yeah. Left type bool. Oh. Yeah, check your errors, bucko. Jesus. You're calling ftel. Holy shit. Calling ftel without checking the return value. Set file pointer underscore move method. That's such a messed up name. All right. Let's try to do the Linuxes. Okay. So the Linux version is fseek. Fseek file.handle. Offset and whence. What? Why is it long? What kind of bullshit is this? Is fseek no longer the thing that you use? Why? What is that? I mean, I think I need to use these, right? Except no, because I can't. Is long supposed to be 64 bits? Is that what I'm confused by? Only Windows has 32-bit longs. Okay, that's why I'm confused. All right, so this is fine. This is fine. Okay, file seek. We go handle, pause, and whence. We'll call it whence, right? Where okay, what is that then? Seek cur or seek end. All right. Wait, I didn't. Oh. Okay. I'm about to sneeze. Okay. It's all good. Sidney Coleman made me sneeze. It's not my fault. It's Sidney's fault. Okay, so we're doing an fseek. And then what? Return value. Fseek returns 0. Hold on. Did I get the Windows one wrong? Set file pointer X, return value returns non-zero. Okay. Great. Okay, so we do fseek and then ftell. We're just going to pretend it's true. All right. Great. Well, we now compile, everybody. The importing PLMPeg. That was a slog. The else return false looks wrong. Yeah, you can show how much I'm not. That's the seek set. What? What are you talking about? You mean in Linux? Fseek. No. I mean, what's the problem? Oh, this part. Right. Okay, I screwed that up. You are correct. That would have very obviously failed to work. This is stupid. This is stupid. Let's just do it this way. Oh my gosh. Sometimes the struggle is real. This file.handle a file pointer on Linux. Yeah, it's a file pointer right now. We'll see. We might make it a file descriptor later because we want to get rid of any and all libc use. So right now we're still using file pointer. But honestly, it will not be that big of a deal to change it to file descriptors. I don't think. Wait, do file descriptors do have a seek and tell version? Maybe they don't. You like do an ioctl on a file descriptor or something, right? Anyway. lseek is file descriptor. Okay. Well, when we switch that over, that'll happen. Oh, this not... What am I doing here, guys? The struggle is real. All right. All right. That might be it. It might be break time, I think, because we were turning the crank there quite effectively for many hours. I kind of think we've been streaming longer because I think our disconnection... So Twitch says 5.5 hours, but I think we had a disconnection, right? I think if I go to the video producer, I could see, yeah. So we have an extra 2 hours of Sidney Coleman Tuesdays for the first one. So we've been streaming for 7.5 hours, which is not bad. And in that time, I mean, we haven't finished this port yet, but this is something that would take a lot of programmers like at least a week. So, I mean, just to get it compiling. So it's great that that we've got it compiling. Getting it running, who knows? Let's give a try to it. I mean, I just want a break. That's the thing, right? How's this? I'll start up a stream later tonight, maybe, where we go try to do it. I just want to take at least an hour break, because this kind of thing is a bit of a slog, you know, and breaks are nice from slogs. Let's see if we could raid somebody while I take a break. Let's see who's on the Science and Technology channel. Sidney Coleman. Does Leon know Sidney Coleman? I don't know. Come learn how to freelance. Free web dev bootcamp. Anthony Patch Patreon. Does he do math things? He has a math icon.
Yeah, this is from our August edition.
Wait, I don't have my
The
things.
key take home here,
something
to
horrible
Dr.
right
McCullough,
now
this is
on my
his
screen.
words. This is the transcript from his interview of Dr. Mikovits.
Dr. Mikovits.
McCullough says, the key take home here is that retroviruses are, quote, integrated into...
All right, this is some flat earth stuff, I think. It sounded like flat earth stuff, and that dude looks like a flat earth guy. So, you know. Flat Earth. Lunar Station. Is that like a VR game? They put chemicals into the water. Feed sheep with cryptocurrency. Top 25 game designs. Cavern of Stars. That sounds fun.
And being like super fucking wired. All right. So
Dude,
we
it's
have
like
this done.
We're going to do Cavern of Stars. Thanks everyone for coming by. We'll do another stream tonight. I'll see you later. I hope this game's good. It'll be better than the Flat Earth guy.
Do some more concepting. Maybe in like